So yeah, today's presentation is about planning for innovative modular projects in the Kingdom of Saudi Arabia. Just a brief about the outline. I'm going to be kicking off with an introduction, and then I'll be talking about generically of modular construction, and then I'm going to go or dive into some case studies, building scale and master plan scale. Before then, I address high-rise modular construction in Saudi Arabia, and of course, we're going to cap it off with a Q&A session. Now, just a brief about Drees and Sommer. We're, sort of medium-sized, 4,000 strong interdisciplinary organization. And the reason why it's interdisciplinary as opposed to multidisciplinary is what I'm about to explain now. Now, some of the key challenges that we've been facing in the market, and this is very, very much relevant to modular design and construction, is that 80% of the projects are not able to meet clients' expectations. And part of the reason is because of the nature, let's put it this way, of the model in the industry, which is compartmentalized in its nature because it's more like a multidisciplinary linear model, right? Where you start with feasibility and then you go into design and then you go into construction and finally into operation. And there are, little overlaps between these different stages and the stakeholders that work on these different stages. The issue with this model is as soon as you start introducing novel solutions like smart, modular, for example, right? Digitization, sustainability, and what the client really wants on top of that is they want the project to be economic and they want it to be fast track, right? And all of that. So what is happening is all the innovation, right, that goes into delivering these solutions increases the risk quite high. And all of that requires a lot of research and development really to start with. And, the research and development, where it starts and where it ends within this process, can be very difficult to pin down and to identify and also to price. So in that respect, some of the key model gaps that we have is, first of all, the integration, right, of these different disciplines, and therefore the integration of the solution from feasibility to operation, and validating, right, any of the solutions that these, this project team basically produces. And more importantly, how do you communicate consistently, right? The design intent, the rationale, the construction intent, the operation intent, and so on, knowing that different disciplines and different project groups, they produce their information in different formats and, basically using a different language. Now, some people would say, well, BIM should help in, addressing this problem. The issue with BIM, however, is that it is not used across all stages or by all parties. It cannot fully simulate performance, and it's too specialized for executive use. So for this reason, we're moving away from this sort of multidisciplinary model and trying to adopt a more interdisciplinary model in the sense that we bring on board specialists in whole life cycle, design, constructability, operability, and research and development from very early feasibility stages. And we maintain this team all the way through to construction and operation. And that's basically, that basically gave birth to the interdisciplinary design and research team that I had. Part of them is based in Dubai and part of them are based all over the world. And they've got various expertise in terms of architecture, engineering, urban design, sustainable design, modular construction, among others. We collaborate with investors, with business consultants, design consultants, tech developers, and specialist contractors, as I said, from very early feasibility stages in order to make sure that the whole project team, which is going to ultimately be responsible for constructing and operating the project, has had the chance to be involved at earlier stages. Now, when it comes to modular construction, really the principles in a nutshell are that we're trying as much as possible to maximize, right, offsite unitized construction. And the reason to that is we're trying to minimize waste on site. We're trying to maximize repetition for cost effectiveness, right? Now the materials can vary from timber to steel to lightweight composites. However, in this region, for a number of reasons that I'm not going to get into at the moment, reinforced concrete remains to be the favorite material choice by clients. The design must be pre-rationalized or adapted to modular design constraints. So you cannot just design like any regular building and then later down the line decide that actually we want to do it out of modular. If the decision is taken to go for modular construction, this decision has to be taken from early design stages and not at later stages. Not to say that if the decision is made at later design stages, you cannot do it, but it will take a lot of post-rationalization to the design and a lot of redundant or rework, right, for the design. because there are some significant design constraints, right, for modular design. So for instance, if we go for a reinforced concrete module, right, the unit size and weight is limited to, you know, the size of the trucks, for example, and the capability of the cranes to handle these units. So in that respect, it's roughly about 12 meters, for example, in terms of length, 4.5 meters in terms of width, and about 4 meters in terms of height. And the maximum total load is about 70 to 80 tons per unit. Now, what's important to keep in mind is that really the whole principle of modular construction is to adopt the production line philosophy. So in that respect, it's very similar to the production line that you see in the automotive industry. So for example, this is Dubox. It's one of the very few, if probably not the only specialist modular contractor in the region. They're based in Dubai, and you can see the way the factory works, right? So here, for example, you have the assembly of the, or let's just say the grouping of or the storage of the prefabricated components. And then here you start the assembly of these components. And then you have here the assembly of the entire unit. And then you have the finishes inside the units. And you can see why they're closed out with these covers, because now you enter into the finishes, right, of the units. And so the idea is you take on site a fully finished unit, right, both from inside and from outside. And all you do is really just stack these boxes or these units on top of each other like Lego, you know, like Lego units. But everything, the finishes, the building services, for example, MEP, the vast majority of them are already fitted within the unit. So it arrives on site untouched. And all you have to do is just then link the units together. Now, of course, like everything, there are pros and there are cons for such an approach. One of the key, I would say, pros for this approach is that it minimizes site material waste to almost zero. It minimizes construction and coordination errors, especially between different specialist contractors. It maximizes the quality of fabrication, construction, and assembly that are done in a controlled, because they're done in a controlled factory environment. It minimizes logistic requirements like labor supervision, supervisors, that is to say, equipment transport, and so on. It minimizes construction time by about 20 to 30% when compared to the traditional construction methods. Its principles can be inherited and developed from project to project. Therefore, you minimize reinventing the wheel from project to project. Now, the key cons, or let's just say disadvantages of the system, is that it requires more technical expertise and time during the design stage than traditional design, has more design and technical constraints than traditional design, requires more specialized and trained contractors and personnel. Changes during construction stage, any design changes during the construction stage can be very costly as opposed to traditional design, because there's a large amount of offsite works that could become redundant. There's higher risk of systematic structural failure in the event of collapse of the lower units due to a blast or fire. And this is an example in London. I don't want to go into too much detail of it. This was not exactly fully unitized units like the ones that you see. However, it was made of prefabricated walls. So it follows a similar principle in the sense that this whole structure is load bearing, and there was an explosion at the lower levels, and it caused the systematic failure, right? This sort of pancake effect where an entire section of the building collapsed. And since then, there's been a lot of, let's just say, wariness of modular construction. But hopefully within this presentation, we can show a way to mitigate this risk. I'm going to show here just a quick case study of a low-rise complex that we did. It's a 60,000 square meter offices complex. The project is very confidential, so unfortunately I cannot reveal exactly where it is. However, it is in the region and it's very relevant to the Saudi market. And basically what we did is, from very early stages, it has been decided that we want to do, because the client was very high on sustainability, but at the same time they were very high on the lettability and the let's just say the efficiency of the floor plates, right? But being high on sustainability, we started looking at let's just say traditional vernacular, right, established designs that were used in the past, like vegetated courtyards, like for example screens, shading screens, for example, right, elevating the building so that we can get more natural ventilation coming through, and the list goes on. Now, one of the key things that we were conscious of is that if we're going to go down the route of modular design and modular construction, we wanted to make sure that we avoid boring repetition. And this is one of the key, let's just say, downsides or perceptions of modular design and construction. So we developed a fenestration design in an algorithmic way where we have linked mathematical rules with the movement of the sun to the geometry of the openings of the windows. And we've also did that for the overall volume, right? And the shape and the form of the buildings. So in that respect, we use, what we call machine learning, where it starts learning how to optimize the design, right, in an automatic way, and how to give feedback almost instantly or in a live manner. So for instance, once we do, let's just say we put the parametric design principles of the fenestration, how they're going to move in and out, left and right, up and down, right, and so on, and make sure that they follow the modular construction principles where all of these, irrespective of the different sizes and shapes, will retain the same structural and performance characteristics. And what you can see here, this is one of the tools, for instance, that we have developed where it uses machine learning in the sense that it will learn from changing parametrically the design, how to predict the outcome of the performance from solar radiation, for example, from energy, gain from daylighting, for example, performance and so on. And what that does, it enables us to sit down with the client, right, and be able to play with these parameters and see live the feedback. And this is only from a technical standpoint. Now, what we've done is we've also devised the strategy in terms of how to integrate the building services with the modular construction system. So you can see, for example, here now the air conditioning system. So instead of blowing air into the air, what it's doing is now it's blowing air into the hollowed structure of these units themselves. So it's using the thermal mass in that respect. And then what we do is we create these interdisciplinary diagrams in order to show the whole story, right? So it tells the story of the modular construction, but at the same time, it also tells the story of the performance gains of this system that we have adopted. And there you go. This is the final render of the design. Now, this is a very large master plan, and just in a nutshell, because we're running out of time, it's a very, very complex master plan. It's very futuristic, and it's in a very remote place. And really, modular construction is going to be applied for at least 80% of this master plan. And one of the key issues with doing, for example, smart, master plans is that for the most part, people who come up with these ideas, they come up with these nice theoretical models, but they always struggle to adapt them, right, to the actual conditions. So what we've done here, really here is that we have created a model that can take the input of the various stakeholders on the project, from business consultants to financial consultants to designers, engineers, contractors, and so on. And the idea is that we will create a system that takes the input of these different consultants and be able to then unify the communication format and system and be able to create this model, right, that then will be able to project the full picture. So this is not a BIM model as such. This is a pre-BIM, I would say. It's like an executive level of BIM. So it has a high-level representation of design, the rationale, the technical performance, financial performance, constructability, all integrated into one model. So I'm just going to run through quickly, right, this model just for you to be able to see how it really works. So you have a window where you can interact and interface with the model. And at the same time, you have another window on the right-hand side that is able to project all the information related to the model. So for example, we can look at the GFA, we can look at the population, the land use, water demand, energy supply, wastewater cost, capital cost, a detailed, for example, system use like the vehicles, like the, like the transport system, and so on. So what this does is it gives a high level, right, overview of the entire project from all aspects and not just from a design or from a technical standpoint. Now, as for high-rise modular construction in Saudi Arabia, why did I choose high-rise? Because high-rise is going to be the biggest challenge. Low-rise buildings are, doing modular construction for low-rise building is pretty much established. Doing high-rise modular construction for high-rise building is still something that is being explored. And there is one particular project which is called The Line in Neom. This is 170 kilometers long, and it's going to comprise of tens, if not hundreds, of super tall towers up to 500 meters. The shortest one, I think, is about 200 meters. At least this is what we have been told. And so one of the key challenges is how you're going to build these, this large number of high-rise buildings in a very remote place, because it's going to take a lot of logistics, right? And it's going to take a lot of time. And there isn't much time. And there aren't enough contractors, right, that can build such a huge scale project all at the same time. So really, modular construction and offsite fabrication is a no-brainer in that respect. However, how do you do it for high-rise? And what we thought about is we can do the core and we can do the superstructure, right, in a sort of more traditional way. But the way we do the superstructure is that it doesn't support every level. It can support every 3, 4, 5, 10 levels, depending on, you know, how we devise the system. But then the idea is these units will then be brought in, right? And every superstructure, you know, module will be able to support a certain number of units. So here the idea is if you have any, and these units will be then fixed to the main superstructure. So the idea, if there's any explosion or if there's any fire and there's a collapse in the walls, right, of these units, then you're not going to have a systematic collapse of the whole tower because the superstructure will remain intact. So that's really the basic principle. And, you know, borrowing the ideas that we have shown you earlier in terms of, you know, creating this integrated model that can look at the holistic side of the project from financial to technical to performance and so on. So for instance, the construction sequence would be as such where you start with the core and then you build the superstructure. And then here you have also the ability to phase out the project. So you don't have to build all the units at the same time. You can easily fill, for example, 20% of the tower and then 40% and then 60%, because these are units that you can slide them in as plug and play, right? In a plug and play sort of format. And as we play with the parameters in terms of the size, building height, for example, and so on, you can see here that all the information related to the building will start updating in a live manner. So this enables us to sit down with the client and the design team and be able to do all of these modifications and get live feedback, right, as desired, without having to go away, do the calculation and come back again. We can integrate, for example, dynamic shading system that will start, you know, showing us the benefit in terms of shading and therefore the savings in terms of energy, as you can see here. We can even go as far as playing with the materiality, right, of the building. Here, for example, we're playing with the materiality of the shading screen because it will affect the capital cost, the operational cost, but also the entire performance of the facade of the building. So yeah, we believe by, you know, developing these sort of universal systems, you can easily, for example, apply to a circular building. You can apply to a pyramidical shape, for example, to a conical shape, as long as the concept of having a superstructure and then units that fit in there, right, is applied. And these units don't have to be identical for the system to work. What they need to, however, maintain is the same principles in terms of the facade treatment, for example, and in terms of how the units connect to the superstructure. And then finally, we can add the, let's just say, the lower levels and the crown of the building. Question and answers, please.
Okay, thank you, Abdulmajid. Very interesting. And I mean, I've got questions bouncing around in my head, frankly. You know, we spoke to Sommer Abu Hijler early today from Roshan, who's building 400,000 housing units in Saudi Arabia, and his focus is modular as well, because he sees that as a way of meeting the deadlines that he has for the number of units that he has to build. And he said that most of them probably will be modular. You're looking here, you've mentioned NEOM and the line. With the high-rise, what's the situation in terms of, is this something that clients are buying into, or is this still a situation where you are convincing people that this is something to look at?
Yeah, I mean, excellent question. It's a combination of all, in all honesty. And the reason is because one of the, right, there's two ends to the spectrum, right? There's the very high level, right, starting point, which is convincing people with the system, right? Now, that is not, that we're not really facing much trouble in terms of convincing, right, the higher executives with the system. The problem that we're facing is finding the contractors, right, and adapting the current standard procurement route in order to make sure that we can bring in the right people on board. So sometimes you may have contractors that may have never done this before. However, if you send out a tender like any other tender, right, the contractors don't have enough time to react to such requests. And therefore, they will either decline it or they will propose an alternative solution, which is to do it traditional. And that is probably 99%, of the cases. However, if we change the procurement route and how we engage contractors, where we bring them on board from early concept stages, right? Okay, guys, you have been identified, right, as the potential contractors to build this building. However, we have to take you through the process so that by the time we get to the point where it's now time for you to go away and price it, at least you understand it. You have raised your concerns. We have incorporated your concerns. And so by the time you receive the request for proposal, right, you have a very good understanding of the project. And now you're able to act as opposed to react, right? They've had enough time to think of it. They've had enough time to prepare for it, right? And therefore they can price and they can, plan for it correctly. But the issue is, as I said, the vast majority of these, tender processes is they wait until detailed design stage before they start, contacting contractors, and by that point, it's a little bit too late.
So interesting, because you've kind of answered my next question actually, which was partly about the supply chain. If this is a new approach, how do you make sure that you've got the supply chain in place to ensure that actually companies could get the materials, etc., that they need, but also skills, because this must mean that while some of the modular skills can remain as they are, there must be additional skills that are needed to effectively. I mean, you were with the frame that you were showing, and then there were 9 modular units within those each frame that I could see, which was then being I don't know how it's attached, but attached to the main unit.
Correct. So look, unitization and prefabrication or offsite manufacturing is not a new concept. So it's not entirely alien to the supply chain. You have facade contractors, for example, do what we call unitized facades. So they bring facades as perfectly, let's just say, assembled units: the glass, the aluminium frame, right, the spandrel area, and so on and so forth. And they fit it in a very similar manner to how we're talking about units, right? The only difference here, and of course, prefabrication of walls and slabs, right, and columns, again, it's established practice. The only difference is what we're saying is that instead of bringing the unitized facade panels alone and bringing the prefabricated panels alone, right, let's assemble them together also offsite, and then bring a much larger unit, right, where it has now the internal finishes and the building surfaces also fitted into it. So again, it's not a new concept in its principle and its basic, I would say, rules, right? What is needed, and there's always a beginning to everything, right? As long as we have the opportunity to take the contractors through the process, it's not very difficult for them to then catch up with, okay, now I have to take it to the next level, and it's only about just bringing together a much larger number of components. But the idea of bringing together components offsite is already there in the minds of most contractors, right? And then, as I said, once we go through that process, then if they have any concerns during the design development stage, they can raise them, and then we can incorporate them. So by the time they receive the design, most of their concerns would have been addressed, and they know how to react to it. So of course, there's an education process. But as I said, for this education process to happen, we need to have the higher executives, right, responsible for projects, to allow us to engage these contractors at early stages and be able to provide a little bit of funding, right, for these contractors to engage in that respect. The benefits of such investment is invaluable. You're going to get a much neater, much quicker, more sustainable method of construction.
Okay, so that's again what I was going to ask you. So, I mean, it means rethinking how contracts are issued, because you can't start changing the design partway through after construction starts. And then the other question I was going to ask you, just final question as well, because we're a little over time. But so briefly, how would this compare if you were going to build a traditional tower of the same height versus this? What's the benefit in terms of time and cost?
At least 20 to 30% reduction of time. Now, in terms of cost, it has to go hand in hand with the location of the project. If the project happened to be located in a near a relatively dense urban urban sort of region, then obviously logistics for contractors is a lot easier because people can commute back between their homes and between the site. If, however, this project happened to be in a very remote place, then it's going to cost many times more to move people, right, and materials and equipment, there. So once you take that into account, you will find that actually modular construction, large-scale modular constructions in very remote regions can be a lot more cost-effective than traditional construction. Likewise, you can look at, for example, the location if it's in a very urban dense space, right, where bringing cranes and bringing trucks and machinery and all of that can actually be quite an annoyance and disturbance, right? Can cause a lot of disturbance for the surroundings. So also maximizing offsite construction where you have a cleaner and more quiet, right, method of construction can also have a lot of benefits.
Okay. All right. Well, thank you. I have to